Assalamu alaikum wa rahmatullahi wa barakatuh. Now we give a presentation about our project. The titled Noise Measurement and Analysis, presented by Habib Abdelmassin Habib Al Jabbar and Muhammad Saad Qasim. Introduction. Noise is a pervasive element that affects well-being and productivity in daily life. Extensive research is being conducted globally to understand and address the impact of noise in indoor and outdoor settings. Construction industry, particularly in academic and industrial settings, focuses on material and article that minimize and isolate noise. The study examines the AST building at the UKM to analyze noise levels and create a favorable work environment. Experiment analysis identify sources of noise and highlight areas for mitigation strategy to improve the building design and function. The report explores theoretical concepts, measurement model, and particular techniques for mitigation noise in the AST building and the future project. Project motivation. Noise is a global issue impacting both indoor and urban environment. Categorized by the World Health Organization (WHO) is a major health concern. Over 1.6 billion people worldwide are exposed to excessive noise, leading to health impairment, sleep disorders, issue, and poor cognitive performance. Noise has become a growing concern in educational institutions, affecting productivity, communication, and focus. The study focuses on a newly constructed building to investigate noise perceived, analyze its impact, and propose mitigation technique, understand noise and employing measurement and analysis technique in the building with the enhanced productivity on local and global scales. Objectives. The project has three key objectives: to conduct experimentation to record ambient noise in the AST building across various locations. Number two, the development MATLAB model for analysis the recorded noises and making inference. Finally, to develop the dashboards on things central for the display of experimentation outcomes. Noise characterizations. Noise is a type of mechanical wave characterized by variation in pressure as it travels through a medium. Noise exhibits random patterns and lacks regular propagations patterns. Noise characteristics include intensity, which quantifies the amount of sound energy in decibels. Can calculated by the equation. Frequency refers to the bits on tonal quantity of noise and is measured in hertz. The duration of noise determined is long-term and short-term effect on human health. Noise can be classified based on its spectral content, which represented energy distribution across different frequencies. Temporal variation in noise-related fluctuation and steady-state characteristics impacting perceptions and annoyance levels. Noise can be impressive, characterized by a rapid rise in decibels level for short durations. Impressive noise can mostly occur in industrial setting during operation like hammering and slamming. Impressive noises are associated with peak sound pressure level and maximum sound pressure level. Analysis technique. Noise level, decibel. Noise levels are measured in decibels to determine if they are within safe ranges with the WHO recommending levels below 70 decibel indoor to ensure a comfortable and healthy environment for work and study activities. The energy of the sounds over time is computing using the following equation. E equal zero point 0.5 PAT B squared, where P is the density of the medium through which noise is propagating. B represented the velocity of sound, A is the cross-sectional area of the medium, and T is the duration of sound. This representation can be transformed into decibels by using the following equation. L equal 10 log E over E naught, where E naught is the reference energy level that varies depending on the spectral contents, where the sound level through the air, the reference level is set to 20 micropascal. Analysis techniques. Discrete Fourier transform (DFT). DFT is widely used technique that efficiently analyzes the frequency distribution of a noise signal, decomposing it into frequency component and reducing computation complexity, enabling easier processing of large signal. Mathematically, DFT is computed using the following equation. Here, xk represented the complex frequency spectrum, and xn is the discrete time domain signal and the total number of samples. Analysis technique short time Fourier transform STFT. STFT, also known as spectrogram, is a technique that combines time and frequency information, allowing for simultaneous analysis and of noise spectrum characteristic over time. It is computed using a specific mathematical equation below. Here STFT refers to the complex time frequency response as a signal XU, represented or the time domain signal, and the W is a windowing operation that perform on the signal infer spectral information from smaller channels. Power spectral density (PSD). Power spectral density (PSD) is a technique used to analyze power distribution across different frequency regions. The Welch method, a commonly used approach, reduces spectral leakage by dividing the signal into overlapping frame and computing periodogram for each segment, resulting in reliable frequency content estimate by equation below. BSD. Here M represented the number of segments, and Fs is the sampling frequency, and Xk is the corresponding sample of signal. Zero crossing rate, ZCR, dissipate a noise signal being random. The framing analysis can transform it into stationary chunks of information exhibiting important information. ZCR is one such parameter that determines the randomness in a signal by calculating the instance of datum crossing. The CR is computing using the following equation. Here n represents the total number of samples in a signal, and Gn is represented the sign of particular samples. Spectral flatness. Spectral flatness, also called spectral bandwidth ratio, is an entropy measure that characterizes the shape of a frequency spectrum by examining the distribution of energy across multiple frequency components, calculated as the ratio between geometric mean and arithmetic mean of power spectral density (PSD) of a frame. It can be calculated spectral flatness by following equation, where n is the number of frequency bands over the frequency range.
Assalamu alaikum. I'm Muhammad Saad Qasim. I will complete my parts of presentation. So let me start with the methodology. The experimentation consists of two phases: recording ambient noise levels using microphones placed in different locations inside two rooms, transmitted via an IoT network to the cloud, resulting in 8 sounds file. So the analysis phase involves the development of the algorithm that provide insights into the time and frequency properties of the signals. Then overall approach of the study is depicted by a block diagram illustrating in the adopted methodology on next slide. As you can see here, we have 4 locations to record the sound of noise in 2 rooms and make analysis for this sound in MATLAB and transition this data analysis in ThinkCentral. Result and analysis. Recorded audio signal. The recorded audio files have been analyzed for the amplitude versus time axis. The sampling frequency of 84 kilohertz with an average duration of 6.5 seconds, and then sample recorded signal, as you can see here, in the top for room 1 and in the bottom in the room 2. Noise level. The table as shown below summarizes the noise level recording across both rooms. The result noise level in room 1 is lower than the average noise level in room 2. Fast Fourier transformation. The FFT analysis of the recorded audio files from both rooms revealed that the majority of the noise contents concentrated in the lower frequency region. As you can see here, we have 2 samples of signal recording in right side, the top one for room 1 and the bottom for room 2. Short time Fourier transformation. The FFT analysis revealed a based toward lower frequency values, but located the time frequency relationship. The STFT analysis, however, analyzed frequency content against the time exist and showed consistent lower frequency content without any instance of instantaneous noise in both rooms. So also we have 2 samples in the right side, the top one for room 1 and the bottom for room 2. Power spectral density. The change in energy level of frequencies is depicted through PSD figures for both rooms, showing initially high PSD for lower frequencies. Power decreases exponentially around 5 kilohertz. We have two sample recording signal, the top one for room 1 and the bottom for room 2. Zero crossing rate. As you can see here in figure as shown, the zero crossing rate, it has been found that the noise exhibit a high degree of randomness across all the settings. Minor change may be absorbed over time. Spectral flatness. By finding the spectral flatness as shown in figure, it has been analyzed that the entropy contained in the frequency spectrum of the signal is high. This determines that the nature of noise and has demonstrated an absence of impulse of deterministic noise. Project dashboard. As you can see here, we have the design of project dashboard and all the transition from MATLAB to the Think Central. Noise mitigation proposal. Introduce soundproofing and isolation materials such as acoustic panels and isolation foams. Install vibration isolation materials to minimize the impact of the external sources. Implement a property designed ductwork isolation to prevent air distribution system from generating noise. Applied active noise cancellation system in specific area. Optimize room layout and equipment placement. Conclusion. The study analyzed the sound characteristic in the AST building of UKM University by recording and analyzing sound data using MATLAB. Features such as noise level, DFT, ST, PSD, and spectral flatness were examined. Room 2 exhibited higher noise level compared to the room 1, but fundamental characteristics were similar. Suggestions were provided to mitigate the impact of noise based on these parameters. Here we are recording the sound of noise from different locations. Thank you for your attention.